And we're on. Okay, so we're looking at polymerization today. Polymerization. And we're not going to hang around, eh? Hopefully, you'll be okay with this. There's two types of polymerization on our course, actually, pretty well overall. One is called addition, and one is called condensation. Okay, and we're going to look at them bit by bit. All right, so the first one, addition. This one is all polymers formed by addition, all of them are synthetic. This one does not occur in nature, does not happen in nature. Okay, all addition polymers are synthetic. Condensation, well, some of them can be synthetic and some of them can be natural. Okay, but all addition polymers, all of them are synthetic. I hope we're okay with that. Okay, now what do you need for an addition polymerization? You need a double bond, so you need a carbon-carbon double bond. So in our course, only alkenes can, we say, polymerize. Polymerize. Okay, so it's anything with alkenes. Naledi's here. All right, hello Naledi, you're welcome. All right, so on our course, it's only alkenes that can polymerize. Okay, and there's one there, and it has an alkene. Obviously, has the functional group. It has a double bond. Lots of things are making noises. It has to have a double bond, doesn't it? Okay, so the simplest alkene we'll look at. Let's start off simple and see if we all understand. Is 2 carbons long, and it is ethene, isn't it? This guy's called ethene. All right. All right, and I'm going to draw 3 of them in a row. There's another ethene. And there's another ethene. So the ethene molecules are going to come together under high pressure and high temperature and in the presence of a catalyst. And they're going to form a polymer. They're going to join together. Okay, so these single units, oh, Tiffany. Hold on, Tiffany. Hello, Tiffany. You're welcome. All right, so these single things here, collectively, these are known as, let me get a nice colour, these are known as the monomers. These are monomers. And monomer literally means mono, means one, and mer means parts. So monomer are the single parts that are going to make up the polymer. By the way, I should have mentioned this, shouldn't I, before I started? What is a polymer? Let's write it here. What do we mean by a polymer? Okay, it is a large molecule made up of many smaller repeating units. That's what we mean by a polymer. Okay, it's a large molecule made up of small repeating units. Another way we can say large molecule, by the way, we call large molecules. Oh, Uran is here. Hello, Uran. So we call large molecules macro. These are often called macromolecules. Okay, so are we all good? I'm going to take a sip from my drink and I'm looking at the chat. Are we all good so far? No questions so far? Are we all good? Excellent. All right, excellent stuff. We're all good. All right, so we have the monomers. In this case, they are ethene molecules. Now, what happens is the electrons in the double bond, these electrons here, go. Let me do this a bit nicer. These electrons here go between the 2 carbons, between itself and the carbon next to it. And these electrons here go between the carbons, the 2 carbons. And basically, new bonds are formed. So let me try and draw what we got. Okay, so we have a carbon. Now, because electrons have left this, this is now a single bond. And this is a new bond. This is a new bond that's going to be formed here. This is a new bond. And this is going to be a new bond here. Okay, and the double bonds go back to single bonds because they're. Oh, Larun is here. Wow, I don't think she's ever come to the lessons. All right, so the double bonds convert back to being single bonds. Okay, So let me draw my original ethene molecules first. That's one. That's another one. That's the one in the middle. And that's the one at the right. Now, they keep their hydrogens. They don't lose those. So there you go. That's that one. There's that one. And the one on the right is that one. Okay. Now, obviously, molecules all carries fissures here. Let me admit her. There you go. Now, obviously, the ones that were here, these ones, let me try and do this. Ones from this one came here, and these ones will go here. So you'll get these bonds in the middle, there and there, but also it will continue. Amosa. All right, they'll continue forever. Well, they'll continue for a very long time. So this is the polymer. So I've drawn the polymer now. So let me draw a nice arrow there in yellow. So here, this is our polymer. Oh, sorry. This is called polymerization. The reaction that joins these small molecules together to make a large molecule is called polymerization. And we get this thing. Now, I've drawn it. Now, it goes on for a long way, so we have to do this. We have to cut it off like that because I can't draw the whole molecule, so I do that. Now, it is very, very important that you do these bonds here. These are known as the continuation bonds. And they are important. You must do them. There's one there as well. These are called our continuation. Now, if you have to draw a polymer, you get 1 mark just for the continuation. So you've got to draw the continuation. And there we are, we have our polymer. Okay. Now, when they're in the single units, when they're on their own, before they've joined, they're called monomers. And when they've formed, it's called the polymer. Now, if monomer means 1 part, polymer obviously means many parts. Okay, poly, many, mer, parts, many parts. Now, the monomer, in this case, was called ethene. And how do we make the polymer? Well, crazy, but true. All we do is we write down ethene again, and we write poly in front of it. Okay, so the name of this polymer is polyethene. Now, over the years, do the continuation was they do not have to, Zara, but I think you should put the square brackets in for sure. Okay, do it properly. All right, don't just do what they want. Do what they want and more. All right. So this polymer is called polyethene, but over the years we've kind of got lazy, and now we call it polythene. Okay, and it is one of the original plastics. I'll have to look it up, but I think it was developed in 1932 by a chemist. He was compressing ethene together, and there was a big explosion. And at the end, he found this plastic all over the place. He didn't quite know what had happened. So it's an old process, eh? But prior to the 1930s, there was no plastic in the world. If I'm just looking around my room here, crying out loud, everything's made of plastic, isn't it? I'm looking at the microphone, it's plastic. The computer casing is plastic. My monitors, I've got 2 monitors, my keyboard, plastic, my calculator, my phone, it's all plastic. But before 1930s, there was no plastic in the world. It's crazy, isn't it? Anyway, so this process is called polymerization, and you get polythene from it. All right, in this particular case. Right, now, what do we have to do? Well, what did I do? I made, whoopsie daisy, that's wrong. Let's get rid of that. I joined my monomers together to make the polymer, didn't I? There it is. And that's very straightforward. Obviously, I've done the easiest example, so I'm going to do some harder ones now. All right. So now let's do something different. Let's do this. There's an F, and an F, and an F, and an F. Now, this strange character here is known as tetra, because there's 4. Fluoro, because there's 4 fluorines, tetrafluoroethene. Okay. Now, if I draw 3 of them together, this is one way we convert the monomers to the polymers. Okay. Now I'm going to do exactly what I did last time. I'm going to do it a bit faster now. 1, 2, 3, 4, 5, 6, and I get F. Oops, daisy. F, 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 and F. There's my continuation. There's my square brackets. So this guy is the polymer. So the monomer is called tetrafluoroethene, and the polymer is called polytetrafluoroethene. Okay. Now these are the monomers, and this is the polymer. Okay. I think we're good with that. Nothing interesting about that, really. This polymer, by the way, because of the name here, it's given a shorter name. It's known as Teflon, and it is non-stick coating on pots and pans, on frying pans mainly. But that's what they use, Teflon. All right, it's a really interesting polymer, but it's called Teflon. So that's a nice, easy one. Let's do another one. Okay, I'm doing these so they sink in, these things. All right, let's do another molecule. There's another one. Oh, let me draw this. I'm going to polymerize this one a little bit differently. So I'm going to draw the monomer. There's the monomer. There's an H there. There's an H there. Down here, there's C6H5. This is a big thing. You don't have to worry about what that is. But now I'm going to polymerize this. Okay. Now I could do it the way I did it first of all. I could draw three in a row and just add them together. But I'm going to do it a different way now, which is just as good. Okay. I'm going to simply, and now watch this, I'm going to get rid of the double bond there. And I'm going to draw a single bond there and a single bond there. Close it off. And this is the polymer. Does that make sense, everyone? Are we okay with what I did there? How we convert the monomer to the polymer? Zara, you're quick. Okay, so we're good there. So that's the polymer. Now, the monomer, if you remember the monomer, looked like this. C6H5. Okay. And this monomer is known as styrene. So the polymer, anyone want to write it down quickly? What's the polymer called? 5 seconds, 4 seconds, 3 seconds, 2 seconds, 1 second. You're all too slow. Well done, Zara. Again, this is polystyrene. Okay, polystyrene. And that's how they make polystyrene. Now, have a look at this. I made this unit here is from one monomer. This one here I made from 3 monomers. But I used the, how do you spell monomer? I did this bottom one, I used one monomer only. Okay. So if we can make our polymer part, if your polymer part looks like it's only from one bit, this is known as a unit cell. Okay. All right. I can't remember what they call it. Does anyone, I don't teach the Form 5s this year. What have your teachers called this? I don't think they'll call it a unit cell. What would they call it? Anyone know what we call one thing? I don't think you call it a unit cell. What would you call that? Anyone? No. You should know this, but I can't remember what it's called. The simple unit, the smallest unit that you can draw. Okay, I don't think anyone knows, which is a shame. But I don't think you guys would call it a unit cell. All right, I think that's a bit advanced for us. All right, so that's how you polymerize these things. Now let's go a little bit deeper into this. Okay, let's do polythene. Now, if we've got polythene, I'm drawing my monomer again. Okay, and I can draw this, can't I? I've got N of the. That's well done, Zara. It's called a repeat unit, isn't it? Well done. It's often known as a unit cell, but I think you're better. This is a repeat unit. Okay, and I'm going to come back to this in a minute. A repeat unit shows only, it's the smallest part of the polymer that will generate the smallest part of the polymer that if you cut and paste it next to each other, it will generate the polymer. So it's only one monomer big, the unit cell, the repeat unit. Okay, and there it is. If I draw this thing next to itself, I will generate the polymer, if you know what I mean. Anyway, So let's have a look at this equation down here. This is our monomer, all right, and this is N, and it polymerizes to give me this unit here with my continuations, and we write N. So do you understand that equation there? If for N monomer units, we end up with N of those units in the polymer. Does that make sense? Are we all good with that? Excellent. Is Zara the only one working today? Everyone's very quiet. Maybe I'm doing stuff too simple for you all. All right. So now let me give you a weird one. Let me give you a couple of strange ones. CCOOCH3. Okay. There's an H there. An H there. Let's polymerize this weird thing. Okay. Well, I don't know, what's it called? I could give it a name, couldn't I? It is called 123. 123. This is something called propenoic acid. It does look scary, doesn't it? And there's a methyl, so this is known as methyl propene, because it's a double bond, propene. Oh, wait. It is a special ester. It's an ester, but don't worry about that yet. Okay, so let's polymerize this. No, you won't be asked to name it. There's no way. Okay, don't worry about that. All right. There's no way they'll ask you for naming. So how do I polymerize this thing here? Well, I think the easiest way personally is to do what I'm going to do now. Okay, I take away the double bonds and just draw lines. And there it is. That is the unit, the repeat unit. And I've done. Does that make sense? All right. So this is a weird one, but what you've got to do, it's got to be, and I think students get confused by this, it's got to be the C double bond C that opens up. Okay, the C double bond C was here. All this rubbish here is just put in to scare you. The only thing you have to look at is the double bond. That's the only bit that opens up, all right, to form the polymer. So there you go. So back to this equation here that I've done. This one here, let me get a different color, blue. We haven't used blue yet. This one here, we've got millions of monomers here on this side. All right, and we only get one polymer string. So because you only get one product, you get one product only. Hold on, dear, I'll be with you in a minute. You get one product only. And because everything joins together to form one thing, this is known as an addition polymerization. Okay? And addition polymerization can only be with double bonded things. All right, alkenes. Why is it propanoate if there's two carbons in a straight chain? I think, dear, there's three, aren't there? If you look, it was these three. Yeah? In the original monomer. Does that make sense? Zara, you all right with that? No? All right. The other one is above the carbon. Well, it doesn't. I'm not talking about the polymer, dear. I'm talking about what the monomer was called. The monomer was called methyl propenoate, not propanoate, propenoate, because there was the double bond in the original molecule. So this is called propenoate. The polymer would be called polymethyl propenoate. Okay? Is that all right? Are you okay with that, Zara? Let me write down the monomer again. No, you're confusing yourself, dear. Let me write them. This is the monomer. Okay. There. You shouldn't worry about names at your level, eh? No one's going to ask you about names. That's the monomer. Okay. Now, what is the monomer called? You don't have to worry about this, but I'm going to take away the double bond and pretend that this is the monomer. Now, if I look at this monomer, I can see, first of all, it's an ester. Okay, and esters have two parts to them. They have a first name and they have a second name. The first name comes from the alcohol that made them up. Okay. Now I'm looking at my monomer here, and the alcohol, this thing here, is methanol. Okay. So this guy is going to be called methyl. Okay. Now the second part of the name comes from the acid, and there's the acid. Okay. Now the acid has 3 carbons in. So in this case, it's the acid is propanoic acid. So this ester is called propanoate. All right. But I gave you a nasty one because we're talking about polymerization. And I didn't give you propanoic acid. I gave you this thing. Now, if it's got a double bond in, it's not called propanoic acid. Believe it or not, it's called propenoic acid. Okay, I shouldn't have done this because I think I'm confusing everyone. So this monomer here, the one I picked here, is called methyl propenoic acid. Okay, I'm sorry, what am I talking about? It's called methyl propenoate. Propenoate, because it is an ester. All right, that was just an example of our monomer. Okay, so let's do a few more examples. Let's have a look at propene. Propene is a good one. Now, this is the formula of propene. Let me draw propene. Now, this is my monomer. Okay, this is our monomer. And this monomer is called propene. I've got to polymerize this. I've got to use this monomer and make a polymer. Now, the way I'm going to do it, I'm going to redraw this. Okay, I'm going to redraw it. And now watch how I'm redrawing it. Maybe this isn't helping some of you. I don't know. I hope I'm not confusing you. But I'm going to redraw it. There's the double bonds from there. I'm going to draw an H there. An H there. Up here, I'm drawing an H. And down here, I'm drawing the CH3. Could everyone see how I've redrawn that? Are we okay with that? Has everyone gone to bed? Zara, is there anyone else other than Zara that has access to a keyboard? Has everyone else gone? All right, well done. Is everything going okay though? Because I'm assuming everyone's okay. Am I okay? Well done, Misha. Thank you, dear. Yeah, just say now and again because having Zara as the only one listening to me is scary. Right. So now, here we are. Now, this is propene. And how do I make this into the polymer? Well, watch what I do carefully. I take the double bond away. There. And I just extend it either side of the double bond. And that is polypropene. Okay, I could draw it a bit nicer than I've drawn it. Let me draw it another way. I could make all these. It doesn't matter about the angles that you pick, by the way. There. And this is a CH3 coming down. And if I were to do this, and there's a CH3 coming down, and there, and there's a CH3 coming down. Okay, are we good there? So, can anyone tell me how many, down here, how many repeat units have I drawn? How many repeat units are there on that bottom one? Well done, Bobato. Excellent, well done. So if they ask you, and I hope you could do this, if I gave you that picture at the bottom, could you figure out what the repeat unit is? This is what you would do. You would find out the molecule, you would go to the molecule, and you would say, well, let's start here. Okay. And now, when's the next time I see CH2? The next time I see it is here. So the repeat unit can't include that because I'd be going too far then. And so now, that is the repeat unit. Okay. Oh, is that clear? Are we all good with that? That's the repeat unit there. Well done, everyone. Excellent stuff. So now, I'm going to move this up a little bit. And don't forget, I'm recording this, so if you don't get it, you can watch the video. Right, so I'm going to get rid of this and this for now. Oh, look at that. I'm going to get rid of the repeat unit for now. Okay, there we are. Get rid of that rubbish. Okay, make my polymer whole again. There you go. I'm going to draw another polymer now. I'm going to draw the one I drew earlier. I'm going to draw C6H5. This is polystyrene. That's the repeat unit I've drawn, but I'm going to draw a few more units. There's another repeat unit. I'm going to draw 3 repeat units. C6H5. There we are. There's 3 repeat units. Put my continuation lines in, very important. And let me draw another one. Let me draw this one. One more. I want to draw 3, so you get the point. Okay, so there's 1, 2, 3, 4, 5, 6. H, 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 H. And down here I'm going to do CH3, 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 and CH3. Okay. Now I've got 3 polymers there. Let's start off with this one. Now this one, if you remember rightly, this one is called polypropene. And this is the monomer. So what am I talking about? You guys aren't arguing at all. You should be. This is the polymer. Did I say monomer? This is the polymer. Now, I've been given the polymer. I have to tell the examiner what the monomer is. Okay, so I'm going to show you how you go. Already I've shown you how you go from the monomer to the polymer, but now I'm going to show you how do you go from the polymer back to the monomer. Okay, because you have to do that. Why is it polypropene if there are 2 carbons in a straight chain? Darling, I think you're a bit confused with this stuff. Zara, I think you're overthinking it. Polyethene. It's not polyethene, dear. I'll show you. All right. How did we make it, Zara? How did we make this polymer? What were my monomer units to make this polymer? Can anyone help Zara? What were my monomer units that I used to make this one? What were the monomer units? No? All right. No one seems to know, so I'll get on with it instead. Anyway, Zara, wait, and you might see what I'm getting at. Yeah, exactly, propene. It was propene. So if propene, Misha, are the monomer units, what must the polymer be called? Anyone can answer anytime. You don't have to wait for. If the monomer units are propene, what must the polymer be called? Yeah, well done, Yuran. It's polypropene. Now, Zara, I think, is getting confused because she's seeing something like this and she thinks that's 2, yeah? And then I think she thinks it should be ethene because there's 2. But that's not how we name it here. So let me show you what I'm going to do. This is our polymer, okay? And I want to find out what the monomer is, all right? Now, this is how you do it. Now, watch carefully. I'm going to pick any of these ones. Let me use a different color. I'm going to pick any of these bonds, any of them. Okay. Now I'm going to call this one number 1, this one number 2, this one number 3, and this one number 4. Okay. So the first person pick a number: 1, 2, 3, or 4. Any number: 1, 2, 3, or 4. 3. Well done, Zara. And I'm going to watch what I'm going to do, Zara, and the rest of you. Now this one is number 3, so I'm not going to use number 2 or number 1 or number 4. I'm going to use number 3. Watch carefully. Now, Tisa, we'll do number 4 in a minute. All right. Now I'm going to change this single bond to a double bond. Okay. I've done that. And now, once I've done that, I'm going to get rid of everything to the left. I'm going to get rid of everything to the right. And what's left, this guy, is the monomer. So we've gone from the polymer back to the monomer. Okay, Zara, do you see that? That is the monomer. Yes? Now, Zara and the rest of you, look at that structure and what is that structure called? What is the name of this thing? What is the name of this? Yes, it is. Well, that's the group of compounds, Tiso. Well done, Mabatu. It's propene. Now, Zara, I think, is getting a tiny bit confused because she thinks it's dangling around the bottom. Don't forget, Zara, and the rest of you, and this is one of the things that suck about chemistry, I'm afraid, is we draw things on a flat surface. We draw things on a two-dimensional surface, but they're three-dimensional things, eh? And so even though it looks like one's dangling down, this is like a V-shaped molecule in the end. But you're not to know that yet, so don't worry about it. I'm going to redraw this. Let me redraw it. I could redraw it like this. Whoops, let me do that again. Now, Zara, this is for you mainly, dear. Would you all agree, and this is a very important part about organic chemistry, would you agree that this structure here is the same as this structure here? They're the same. They're the same thing. Can you see that? I've drawn them a bit differently, but they're the same thing. They are three long with a double bond. That's all you got to know. They're the same thing. So well done, Zara. Good stuff. So, as Misha and lots of people said, this thing here, this monomer, is called propene. Now, if the monomer is propene, excellent, well done, Zara. If the monomer is called propene, the polymer must be called, I think Misha said it, must be called polypropene. Are we good? I think we're good. Right, now, Tissot, I'm going to go back now. Right, Douglas, if this works, I've got to push the this button like a million times now for you because I'm going to do number 4 because you asked for number 4. And I want to show you it doesn't matter. Oh, that was good. So, Tissot, you ready? This is for you now. Tissot wanted number 4, okay? So let me do what I did before. Whoops, Daisy, Sakao. Do I know Sakao? I hope so. Sakao, Dumela. All right. So now I'm not going to do number 3. Whoopsie daisy. I'm not going to do number 2 or number 1. I'm going to do number 4. So with this one, I'm going to make a double bond. There. What was the next thing I did? I got everything to the left. I got rid of it. There you go. Everything to the right. I got rid of it. Yes. And what's left? Anyone? What's this molecule now? What's the name of this guy? It is propene again. Yes. Now, the only difference is the first time it looked like this, but the second time it looked like this. But they're the same molecule. Do you follow that? Why is everyone using capitals? The caps lock. Oh, is it caps lock? Yeah, everyone's shouting. All right. So do you follow that though? Chemistry is fun. Yes, my brother, very funny. Take your finger off the caps lock. So even though it looks the other way around, they're both propene. They're just one's been flipped over. That's the only thing. So are we good with that? I hope we're good. All right. So I'm going to move up. Now, to be honest with you, I'm looking at the time. I don't think we'll get to natural. Oops, Theo is here. Only 37 minutes late. All right, I don't think we'll get to natural today, okay? Maybe we can squeeze natural in on Wednesday, okay? Maybe we can do this on Wednesday evening. All right, so there we are. So we've done propene. Now let's do the same with this one. Now, here we go again. I'm not going to give you the choice anymore because I don't want to do this forever. I'm going to pick anyone. I'm going to be lazy and I'm going to pick, whoopsie daisy, I'm going to pick this one here, okay? Make it a double bond. Get rid of everything on the left. Get rid of everything on the right. And I end up with my monomer. Yeah? And there's the monomer. And this monomer, you've probably forgotten, but this monomer is called styrene. So the polymer was actually called polystyrene, but there's styrene. And that's how, what I'm trying to show you, if we have the monomer, you should be able to tell me polymer. But just as importantly, if I give you the polymer, you should be able to tell me what the monomer that it came from. And I've showed you how to do that. I hope I have anyway. All right, now let's have a look at this bottom one. I'm not going to do anything. I'm going to sit here for a minute on a piece of paper or whatever. I want you to figure out what the monomer here is. What's the monomer? That's number one job. Then number two job, I want you to tell me the name of the monomer that from this. And number three job, I want you to tell me, therefore, what's the name of the polymer. I'll give you, what time is it? It's 20:38. I'll give you 2 minutes. Okay, off you go. I'm checking my watch. So see if you can do all that. I think it. Oh no, Misha, no, it's not ethene, darling. Well done, Tissot. You've answered. You haven't answered number three though. What's the name of the polymer? Well done. Is exactly right. Well done. Oteng as well. Excellent stuff. Misha, darling, let's do it together. Don't worry. First of all, what's the first thing we've got to do? We've got to pick one of these bonds. They're all the same. Doesn't matter which one you pick. I'm going to pick this one. There. Okay, Misha, this is for you. I pick that. What's the next thing I do? I get rid of everything on the left. And I get rid of everything on the right. What's this molecule called now? What's this called? Misha, this is for you, dear. Zara, you're correct, darling. But I was waiting for Misha. You understand, Misha, why it's called that? I hope you do. All right, so you're good there. Now, I'm going to give you one last one. Well done, Misha. I'm going to give you another one. Let's do this one. This one's going to mess you up. Okay, so here we have CH2, CH3. Oh, Zara, I'm going to kick you. We'll come to it in a minute, dear. Zara. No, you know what? It's late. I think we're all done. Look, while I'm drawing this, darling, we'll talk about it in a minute, all right? How is 8 o'clock? Is it too late for some of you? Or too early? I don't think I want to do it later than this. I want to watch the Liverpool game at 9 o'clock. Okay. Is 8 o'clock okay for us all? Zara, I'll get back to your question. Okay. I'm assuming Zara speaks for everyone. Is that right? Your parents aren't complaining that you're up too late. Okay. Well, I'll never know because most of you aren't saying anything. All right. Now, Tissot. All right. I'll bet it's passed, to be honest. Well done. Mine as well. But you got to watch the Liverpool game, for God's sake. Right. What's this one called then? Oteng, Tissot, and the other ones that got it right? Misha, well done. It is still butene, isn't it? Well done indeed. Well done. So what's this polymer called? What's this one called? Polybutene. Well done, Zara. Now, I'm going to mess you up. I don't know if you can cope with what's coming now. Mm-hmm. And this one's going to need a little bit of concentration. Okay, so let's do it different color. 1, 2, 3, 4, 5, 6. No, Oteng, you're right. Well done. This one you'll either get or you won't get. All right. This is the one we had before. Let me do my continuation. Here it is. Okay. Does anyone remember what this one was called? This one is called polybutene. Remember that one? Well done, Zara. And what's this bottom one called? What's the bottom one called? Polybutene. Now, ladies and gentlemen, are they the same molecule? Tiso, though they're not the same. Look at them. They're not. Oh, Misha, how could they be the same? They're not the same. Can you see they're not the same? We've done something wrong. Movato, almost isn't good enough. Yeah, well done, Zara. They have different structures. They are isomers. Well done. That's a very good point. They are isomers of each other, but they're not the same. The top one has CH3s dangling down, and the bottom one has H's and these things. Yeah, they are isomers. They are, but they're not the same. And we've said they're the same, but they're not the same. We've got to do something, guys. Let me help you. Top one, I'm going to take a double bond anywhere. I'm going to put it here now. Watch this. There. I'm going to get rid of everything on the left. Get rid of everything on the right. Okay, there you go. Now I'm going to do the same on the bottom one. I'm going to pick this one. Misha got this one, didn't she? I'm going to get rid of everything on the left, like that. And now I'm going to get everything on the right, like that. Now, what's this one called? And what's this one called? I'm going to call it A and B. What's A called and what's B called? They are isomers for sure, but what are they called? Zara, I like your honesty. You're a funny person. Well done. All right, there. Now the top one. How many carbons in a row? 1, 2, 3, 4. So the top one is called bute. Yeah. The bottom one. How many carbons in a row? 4. So it's bute. Yes. They're both butenes, aren't they? But they're isomers of each other. And in the top one, the double bond is between carbons 2 and 3. So the top one we call buteene, and the bottom one is called buteine. Am I saying stuff you don't know? Oh, very good, Misha. No, dear. You know what? Let's have a look at this, Misha. H2O, yes? You drink this, don't we? We drink this. If I just put a 2 there, you're poisoned. So you can't do that. Different structures have vastly different properties. One you can drink, one you'll die from. All right? So we can't be flippant about isomers. So now, isn't it between the first and the second? Which one, dear? The top one or the bottom one? For A, no, darling. It's the second carbon. Let's number them. 1, 2, 3, 4. There are 4 carbons in a row, aren't they? The double bond is between 2 and 3. So it's buteine. Count from the other direction, dear. What's it called if I count from the other way? No, you don't. You can't start from the end carbon, not the top carbon. This thing here, I tell you, you know what? I can tell you haven't drawn enough of these, I can tell. But I'm redrawing it here. CH3, CH, double bond, CH, CH3. What would you call this, Zara? What's that one called? Everyone, what's it called? Exactly, buteine. Would you agree that this thing here is the same as this thing? Can you see that? I've bent it, but it's the same. Now, this one at the bottom, now let's number the carbons. 1, 2, 3, 4. And what's the bottom one called? Zara, Misha. What's the bottom one called? What's B called? This one. B. Yeah, well, apart from the E. Yes, butanene. Yes. So, someone clever, tell me, therefore, what was the name of this polymer and what's the name of this polymer? Remember, you thought, all of you, by the way, you thought they were both called polybutene, but they're not called polybutene. Because if they're both called polybutene, that would mean they're both the same thing, but they're not the same thing. So what is the polymer of A called, and what's the polymer of B called? Anyone? Oteng, Tisha? Exactly, Zara. The top one is actually called polybutene, and the bottom one is called polybutanene. Does that make sense? Well done, Michelle. Well done indeed. Does that make sense? Exactly. It's easy if you concentrate. Oh God. Here we go, Clara. Zara. Go for it, dear. Do you want to speak? Don't shout, though. Go on then, speak. Zara's going to speak, everyone. Turn your microphones down.
Hello. Okay.
Hello.
What is the difference between butane and 2-methylpropane?
Okay, it's a good question. All right.
Because using this logic, wouldn't they both be butane? I don't know. I'm confused.
It's a good question. It's a very good question. All right, butane, you say, and what is it? Methylpropane.
2-methylpropane.
That's right. Okay. Now, first of all, butane. 4. But means 4, so 1, 2, 3, 4. Yeah. Propane means 3. 1, 2, 3. Yeah. That's the first thing. All right. Now I'm going to finish my butane. There's butane. There it is. Butane. And this is methylpropane. So methylpropane means it's a propane with a methyl on it, and a methyl is a CH3. So there we go. All right, so these are the structures, butane and methylpropane. Now, Zara calls it 2-methylpropane, why does she call it 2? Because she's using the numbering system, and the methyl is on number 2. So she's quite right to do that. It's called 2-methylpropane. However, what's the molecular formula? And what's the molecular formula? What's the molecular formula of the one on the left? And what's the molecular formula of the one on the right? I'm waiting for you, Zara. Count quickly or type it in. C4H10. And what about the molecular formula of the one on the right? 2-methylpropane? Exactly. So these two obviously have the same molecular formula, but obviously their structures are different. Okay. Now, such things with the same molecular formula with different structures are known as isomers, as we all know, I'm sure. Now, how would we describe this then? Could you call 2-methylpropane butane? No. You would say butane and 2-methylpropane are isomers of each other. Does that make sense? Another way I could say it is this. I could say butane and 2-methylpropane are isomers of each other, or I could say butane is an isomer of 2-methylpropane. It doesn't matter which one I start with. They're the same molecular formula but different structures. Okay. Why what, dear? Why are they isomers? I don't follow the question, dear. Do you want to speak again? They're differently because they're
Yeah.
different
I don't understand why they're named differently because
because they're
in
the
the
same.
previous
Yeah, go on.
question that we were doing, it seems like the same thing where they, I don't know, they're the same structures. I mean, they're different structures, but they have the same, but they have different names.
Yeah, because
But they're both butane.
yeah, they're
I don't
both
know.
butene. They're both butene, aren't they? The other two, but the double bond is in a different place. Yeah. So believe it or not, they have different
Oh,
properties. Okay, even though
okay.
everything about them is the same, but if their structure is different, their properties will be different. Can you, in your head, dear, imagine a lemon, a lemon smell? Can you imagine that? All of you, imagine a lemon smell, yeah, and now imagine an orange smell. Okay, believe it or not, they're exactly the same molecule. They're isomers of each other. Those two smells are isomers of each other. All right, they're exactly the same molecule, but one smells of a lemon and one smells like an orange. But they're isomers. They're very, very similar. Okay, happens a lot in chemistry. All right, our bodies are very isomeric. Drugs work on us differently because of isomeric properties. All right, there's quite a lot to this subject. It's very complicated. It's beautiful, but it's very complicated. So isomers just means they have the same molecular formula but at different structures. All right. Now, oh yeah, oh darling, it's I will do anything you want. Is that enough? But don't forget, I'm recording this, dear. Yeah, and I'll send the screen. I'll send the thing out to you soon. Now, guys, I hope. I'm glad Zara's misconceptions have been sort of cleared up to some extent, because that's what I'm here for, right? It's not the easy stuff; it's the misconceptions, and I could tell quite clearly that Zara had some misconceptions about, why is it why isn't it ethene and stuff like that. It's very simple. It's very straightforward. But you can never guess. If you guess chemistry, you're doing it wrong. All right. It's very logical. I promise you. Organic is very logical. All right. So, guys, I'll suggest we meet again. Let me turn the video recording on.